Hi, and welcome to Allen High School's discussion of bonding at the APIB HL level. We're in the midst of talking about covalent bonding, and what I want to do next is a very quick review of functional groups. We, kind of attempted to do them at the beginning of the year, but the activity I designed was really overwhelming for what we needed. So I want to zero in on, kind of the critical aspects of organic chemistry that might show up on an AP test and that will help bridge that into the next level of IBHL2, where you'll study organic chemistry quite extensively. So remember, an alkane group, if we can call it a functional group, the functional group is what causes a structure to function the way it does. And so we're going to just look at the alkanes. Remember, are single bonds, and it ends in ANE. So I don't have much room, so we're just going to do very simple examples. Those lines represent hydrogen atoms, and so this would be ethane. Now, alkanes, the formulas are CnH2n+2. These are always non-polar. Think oils when you think of these. If you want to kind of think of a penultimate example, oils are hydrocarbon chains. So these first few examples are the oily group, stretching it here. Okay, alkenes have the double bond. They end in ENE, and that would be a double bond. In order to make that double bond, you lose two hydrogens. So it would be CN, and you've learned these before. This is a review, and this again is non-polar. And finally, our alkynes are the triple bond. They end in YNE. And again, to make that triple bond, you lose another two hydrogens. They're all hydrocarbons. Hydrocarbons are non-polar. And this would be CnH2n-2. Okay? Now, let's switch to another group. We have our alcohols. Alcohol is going to have some number of carbons. R just stands for a general number of carbons. So it's going to have a carbon and an oxygen to a hydrogen. They end in OL. Just because it says alcohol in chemistry doesn't mean it's drinkable. And in fact, all alcohols are toxic at some level. So don't drink. Okay, so let's just keep to the two carbon theme here. That would be, I don't have room to draw my hydrogens. Those would be our hydrogens. That would be ethanol. And it would be CnH2n+2. Now, honestly, and then the oxygen. I tend to draw them out and then figure out what the molecular formula is. The only reason you would need a molecular formula by and large is in reaction predicting. You may be asked to combust an alcohol. Some students really liked to memorize these molecular formulas. Personally, I would draw it out. I just haven't memorized them in this fashion, but that's up to you. Now, this group here, this alcohol group, now adds a polar component. So the functional group is polar. Whether or not the molecule is polar depends on how long this nonpolar chain is. So this chain part is nonpolar. This functional group is polar. The overall polarity, we'll see in our next chapter, is a balance between these. And by the way, we're on chapter 5. I messed that up when I was rearranging chapters this year. Okay, aldehydes. An aldehyde is an R with a double bonded. Well, let me draw it differently. That's probably not the best way to do that here. Okay, it would be some number of carbons. And then the aldehyde's always at the end. It ends in AL. And so I'm going to have to do a little bit of erasing here too. Sorry. Hopefully you wrote that down. So I would have a carbon and a hydrogen. And then this would be ethanal. And again, that oxygen, the presence of that oxygen confers polarity onto the molecule. You can think of an alcohol as an alkane plus an O, and if you did, an aldehyde would be the alkene formula plus an O. Might help you remember it. Okay, ketones. The R, that little prime, just means it could be a different number of carbons, but do you notice, remember, it's always in the middle, O-N-E. So I have to go away from our theme here because I have to have at least 3 carbons to define a ketone. And again, that double bonded oxygen, that presence confers polarity. It is CnH2nO as well. And because these have the same molecular formula but different structural formulas, we call these isomers. So an isomer is the same molecular, different structural formula. You learned a lot about isomers back in biology when you did all the sugars, all those hexoses that had the same molecular formula, but their oxygens and OH groups were rearranged differently. And so they were isomers. Okay, carboxylic acids, we're going to see these quite a bit when we get to the acid-base unit. So that would be COH. This is the acidic proton. Remember, acids donate a proton. And they end in oic and the word acid. So we can go back to our ethanoic acid. Now, you know that as acetic acid. That's its trivial name. Ethanoic acid is its more stock name or IUPAC name. And this is very polar with the two with the 2 oxygens on it. So this is very polar, and it's like an alkene, CnH2n, but this time I have 2 oxygens. And then the last one that I'm going to introduce to you is review with you is the amine. So that's going to be an R group carbons. I'm just wanting to put in an extra there. And your typical nitrogen is going to have 3 bonds and a non-bonded pair. As soon as you add a 4th to the nitrogen, that nitrogen gets a positive charge on it. So that non-bonded pair there make our amines prime weak bases. So we'll revisit these quite a bit when we talk about our weak bases because they can accept an H+. Okay, and you really aren't going to have to name these too much. They're named a variety of ways, like ethylamine would be an example. And so this is methylamine. Okay, so that'd be methylamine. And that nitrogen confers polarity. Now, this formula is hard to simplify because it really depends on whether these are hydrogens or whether these are other carbon groups, because it's possible for those to be other carbon groups instead. So I'm not going to worry about a generalized formula for this one. So again, you need to rememorize these. You had to learn them on your first test. You need to relearn them now. Okay, we've got one more type of bonding that we're going to do that actually leads us into some reaction predicting. So until then, this is